Alright, let's continue. Let me open the table of content first. Okay. Oh, excuse me. Alright. Okay, we are still on chapter 22, Beyond Physical Memory Policies, and still on homework simulation. So let me open that. Alright, we are on this section, homework simulation. Basically taking a look at different page placement policies or something like that. Let me open that here. What is the script again? Paging policies. Okay, this one. And now let's take a look at question 1. Generate random address with the following argument. Random seed 0, the number of address, I assume that is, the number of address is 10, it is the default in this case, right? Okay, and then with the random seed 1 with number of address 10, okay, random seed 2 and number of address 10. Change the policy from first in first out to least recently used to optimal, and then compute whether its access in set address trace are hits or miss. Okay, that looks like a lot of things to do. Let's start. Okay, random seed 0 is this one. I mean, basically, wait, did the random seed default 0? Yeah, the random seed here, random number seed is 0, the default. Okay, so this one, state of memory. Okay, access x74. Okay, hit or miss. First in, first out. Okay, let me try that, I guess. Case that with the size 3 page. Okay, the first one is egg, page egg, and then page 7. Again, this is the first in first out policy. Okay, something like this. We add the what is it called? Fill the cache to full capacity with S3 page x74, and then we are in this case trying to access page 2, so we remove page 8 which is the first in and add 2 here, and then we we are trying to access page 5, remove page 7, and insert page 5, and then we are trying to access page 4, which is already in the case here. So this is a hit. I mean, other than that, it is a miss, you know. And then we are trying to access page 7. It is not in the case anymore, so we need to take out page 2. And this is FIFO policy. And then insert page 7. It is a miss. And trying to access page 3. It is not in the case. Another miss. Trying to access page 4. Not in the case anymore. So we hit a miss again. Trying to hit page 5. It is recently taken out. So we need to remove the page 7, the first one here. And it becomes something like this. So we only have one hit, it looks like. Let's confirm that by calculate flag here. Okay, x7, x7, 4, 7, 4, 2, 4, 2, 5. Again, the same 4 to 5, right? This means we hit, not miss. And then 2, 5, 7, and then 5, 7, 3, and then 7, 3, 4, 3, 4, 5. Okay, so we only have one hit. Alright, with first in, first out policy. And now let's try using LRU, least recently used policy. I think we can use the flag test P here. Okay. LRU. Okay, it's the same. What is it called? The memory here. The page being access, I mean. Okay, this one. Oh yeah, let's change this to LRU. This recently used. And then 7. And then add 4 for this one. And then can we take out, I guess, the least recently used. I mean, I assume the least recently used is on the left side and the most recently used is on the right side. So we take out the page 8 in here. Again, least recently used being taken out, and it become something like this, I guess. Okay, and then page 5 not in the case, so we take out page 7, the first page. Okay, and then, well, page 4 is in the case, so we need to move page 4 on the right side, the most recently used. This is hit, and then page 7 is not in the case, so we take out page 2, the first one, or least recently used in this case. It becomes something like this, and then for page 3 is not in the case again, so we take out page 5, the least recently used, and put page 3 there. Oh, we are accessing page 4 again. Interesting. Okay. Wait a minute. We are accessing page 4 again. 7. Yeah, we need to move this to the right, the most recently used, something like this, and this is a hit. And then for the page 5 here is not in the case, so we need to take out the least recently used, and that is page 7. Become something like this. So we only have, I guess, 2 hit compared to the first in first out that only have 1 hit. Alright, let me check if that is correct or not. Okay, the first one is 8, x7, x7 4, 7 4, 7 4 2, 4 2 5, this one to 5 4, and it is a hit, right? And then 5 4 7, 4 7 3, the next one, and then 7 3 4, it is a hit, the second hit, and then 3 4 5, that is a miss. Okay, alright, final stat, 2 hit and 8 miss. Okay, that is for the LRU. And now let's try the OPT policy, I guess. Okay, still the same page being accessed, the same sequence of page being accessed. Oh, not LRU, but optimal policy. This is the gold start or compulsory, I guess. Compulsory miss. Okay. say, okay, this one, right? We remove the furthest future, I guess. The furthest bits that will be accessed. Okay, it's become something like this, and then something like this. Okay. Is it gonna become something like this? Maybe. Oh, right, this should be hit. And then, okay, this one. Accessing this. Oh, access page for again. Thing like this. At first glance, this looks like the least recently used policy. So I'm not sure if this is correct. Okay, we take out that. Is this correct though? With the optimal policy, the furthest, right? And then are we? Do we move the order to when using the optimal policy? Let me check. Future, okay. Max replace. I don't think we need to change the order here. If that is the case, maybe it should be something like this. Maybe. And then we remove 4 here. Okay. And then we need to change that. 7. Okay. And then 3. Alright. Remove that. 4. Yes, and then the last one. Now this look like the first in, first out. Well, let's find out. Okay, looks like I was wrong. X7, X7, 4, 7, 4, 2. Oh. Wait. Okay. 742, 745. Oh, right. So we need to consider, I guess the next page that will be accessed. We will be accessed 4 and 7 here, right? So we keep that in place, but we didn't access page 8 in the near future or at all after this first access. Okay, right. So this is wrong. Let me try again then. Okay. Yeah, we need to consider the future. Okay, let's say 2. We are trying to access page 2 here. And well, page 8 is not gonna be accessed at all, so we can remove that. Okay, 2. And then page 2 is not gonna access again in the future, in the near future. So we can remove that. Become something like this, I guess. Right? And then okay, 4 already in the case. So it is hit. And then 7 also in the case. So hit again. 3, okay. 3 is not in the case, and we need to consider the future. 4 and 5. The next one, we need to access page 4 and page 5. So we can remove the page 7 and keep the page 4 and 5, and then insert page 3. It is miss, right? Because page 3 is not in the case previously. And then page 4 and 5 is in the case. So it is hit and then another hit. Okay, so 4 hit. Alright. I mean, this is the optimal policy. So it has a lot of hit. Okay. Let me confirm that. Okay. This one is miss. And then page 2 here. Replacing the page 8. Because we are not accessing the page 8 in the near future. Okay, and then we are replacing 2 because we are not accessing 2 in the near future too. Right, at least the next 2 pages we are not accessing page 2, so we can replace that. And then trying to access page 4, hit, because it is in the case. Trying to access page 7, another hit, right? And then trying to access page 3. It is not in the case, so it miss. And then we need to replace one of the page in the case. And because page 4 and 5 gonna be accessed in the next two pages, so we can remove the page 7, which at least won't be accessed in the next two pages. So it becomes something like this. Removing page 7 and inserting page 3, and then for another page access we have a hit because it is in the case page 4 and page 5. Alright, so that is the optimal policy here. Okay, I guess let's try with the random seed 1. But still have 3 gate size. Seed 1, okay. Alright, this one, right? Okay, not that one. Okay. 1, and then yeah, the first one is first in first out. 1 egg, 1 egg 7, and then 1 7 2. Okay, 7 2 4. Oh, interesting. Immediately access the same page. Alright, 7 2 4 hit. And then 2 4 6 miss again. Okay. 4 6 7. This one, and then okay. 6 7 0, accessing page 0 here. Then this one hit because we are immediately reaccessing the page 0. Okay. Let me check if that is correct or not. Okay. 1 egg 1 egg 7 egg 7 2 7 to 4 7 to 4. This one not, yeah, this one hit, right? 2 4 6 4 6 7 7 6 0. I mean 6 7 0. And this one is 4 6 7 6 7 0, and then 6 7 0 hit. So we have 2 hits here. Alright, and then let's try the LRU. Let's recently use this one. 1 egg 1 egg 7, filling up the case. And okay, and then we are in this one. X72 case 724, and that is hit. Then this one 246. Okay. 467, and then 670 hit. Okay, the last 2 bits access here is 0. Is this correct? I mean, maybe. Yeah, we immediately access the same page on the next page access, so we didn't really change the order that much, right? Okay, let's try to calculate that. 118 where is it? This one, I guess. X72, not that one. X72 724 hit. Yeah, this one. Okay, and then 246, 467, 670, 670. Okay, in this sequence, in this back access sequence, I guess the first in first out perform the same as the least recently used policy, because we are immediately reaccessing the same page on the next sequence, on the next page, on the next page access. That's why we didn't really change the order, and the order is kind of similar with the first in first out policy. I mean the order of the case here. Okay, that is that. Now let's check the optimal policy. Filling up the case again. Okay, and then yeah, we need to consider the future too now. From this page in the case, page 1, page 8, page 7, are we gonna accessing any of this in the near future? At least the next sequence, right? The next sequence is page 4, not in the case. Okay, page 4 again. Page 6, not in the case too. And then page 7 is in the case. Okay, so maybe we can remove page 1 and replace that with page 4. Maybe. So it becomes something like this. and then because we hit page 4 immediately, we access page 4 again on the next sequence. We have a hit, right? And then because we didn't access page 8, in the near future we can remove page 8 and what is it called, and put page 6 here, right? This is miss because previously we didn't have page 6 in the case, so case miss, something like that. And then now we are trying to access page 7. This is hit. We didn't change the case. The case, what is it called? Item, I guess. Now page 0. We didn't access page 7 in the near future, at least in this sequence. So maybe we can do something like this and then hit. So with the optimal policy, we at least have 3 hits. Let's check if I'm correct or not. Okay. Let me check. 118, 172. Oh, in this simulation, we remove the page 8 instead of page 1. Okay, interesting. I mean, from this sequence, right? Where is it? From this sequence, we didn't really access page 1 and page 8 in the near future. So removing either one is fine, I guess. But yeah, I'm kind of curious why we didn't remove page 1 here. That is interesting. Okay, 172. Alright. Wait, did I miss? Oh, right, I miss. Okay, I miss accessing page 2. Okay, so wait a minute. X7 2, I guess, and then we didn't access page 8 in the near future, so maybe it becomes something like this. 7 2, maybe, and then we didn't access page 2 anymore, so we can remove that and add page 6 here. Become something like this. Yeah, maybe something like this. Okay, let's continue. In this case, we access page 4, this one. On my calculation, or what is it called? Solution, maybe that's the word. On my solution, I remove page 8 instead of page 2. But yeah, is there any kind of rules other than the furthest page from the future. I mean, let's say in this case, right, 1x7, we didn't really access page 1 and page 8 in the near future. So I assume we can either take page 1 and or page 8, either 1 or 8, right? In the simulation, what is it called? The simulation decided to take out the page 8 instead of 1. Meanwhile, in my case, I decided to take page 1 instead of page 8. But yeah, I'm not sure if there are any rules. Let me check. What did it mean? Furthest in the future. Furthest in the future, right? The one furthest out. Yeah. I mean, again, looking in the future is hard. Okay, so in the simulation we take out the page 8, but on my solution we take out the page 1. But again, the total heat is the same, 3 heat, right? Okay, and this one, instead of 172, I have x72 here, and then the next one is 724 on my solution instead of 174. Yeah, that make me curious, like why the simulation didn't take out the page 1. Are we gonna access the page 1 in the near future after this 10 page access? Maybe, but for now we are not sure, right? So either way is fine. Okay, this one is miss, right? But the next one is hit because we are immediately accessing the same page as the previous page. This one is a miss too. Again, I decide to take page 2 here. And keep the page 4. Okay, so it kind of looks different. The simulation solution is 176, but on my solution it is 746. Okay, yeah, that's why this is hard to implement, because peeking into the future is hard. Okay, and then the next one is immediately hit because we have page 7 in the case, still in the case, right? And then the next one is miss, and I decide to replace page 7 because I'm not sure if we are gonna access page 7 in the near future, right? At least from this sequence, it's hard to determine whether we will be accessing page 7 in the near future. after the 10 page access here. So I'm removing that, and then we have a hit, the cache hit, because we are immediately accessing page 0 again from the previous page access. So there is that. Okay. Do we need to try this out too? Yeah, I mean, maybe you can try this out on your own. I think I'm gonna skip this. Okay. Now for a cache of size 5, generate worst case address. Reference stream for each of the following policy. Generate worst case address reference stream for each of the following policies. Worst case reference stream cause the most miss possible. Okay. For the worst case reference stream, how much bigger of a case is needed to improve performance dramatically and approach OPT? Okay, interesting. So we have the case size, but we need to arrange the page access sequence, I guess. Okay. First in, first out. Let me try the first in, first out first. Okay, we have the case state 5 bits. First in, first out. Okay, the most miss possible. Okay, let's try something like this. Filling up the case. One, two, three. Or maybe I should start from 0, I guess. Okay, not that one. Think something like, oh, no. Okay, 0, 1, 2, 3, 4. Okay. Filling up the case, and then okay, the most miss. Maybe something like this. 5, right? Again, first in, first out. And then we are trying to access page 0 again. And then we are trying to access page 1 again. Yeah, just kind of looping, I guess. How many is this? 9, okay. 5, 0, 1, 2, 3. Maybe something like this. The page access is missed. Yeah, maybe. Let's find that out. is it? Okay, uppercase C. 5, and then the address or page to access. Okay, 0, 1, 2, 3, 4, 5, and then 0, 1, 2, 3. Yeah, this is already 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, something like this. First in, first out, right? Okay. Yeah, the default policy is first in, first out for the simulation. Yeah. Complete miss. Again, we need to find out the worst case, right? The most miss possible. And the most miss possible that I can think of is every page access is a miss. So yeah, there is that. Okay, I guess let's try the least recently used worst case on the next session. So that's it for now. Thank you for watching and see you next time. Bye bye.